Hello, everyone. Thank you for coming for the last session of today, and what an exciting day it was. Now, there are so many of you today, so if you want to just, maybe if you want to change your position and come closer, we got some cool gifts. For example, someone forgot his iPhone from last session. So it's almost as good as the laptop that you got, but maybe. And we have a book. So that's it. So my name is Yohar Kiryadi. Someone came. My name is Yohar Kiryadi. I'm a technical evangelist working for Microsoft. And in the last year, I had the pleasure and the opportunity to work with developers worldwide, like you guys, on writing application for Windows 7. And through the next 45, 1 hour, 3 hours, whatever you wish, we'll see here some examples and demos of that work, and mainly we're going to focus on managed code, obviously. So maybe some of you are familiar with the blog, the Windows team blog, and specifically we're talking about the Windows developer blog for Windows 7, and basically I had it over here somewhere. So. Windows team blog, and off the team blog, you get, of the team blog, hello, network. Of the team blog, you got many blogs. One of them is the Windows 7 for developers, and here we are with a bunch of blogs about a lot of stuff. And recently, I had the opportunity to be a co-author of a book introducing Windows 7 for developer, which as far as I know is the first real developer book for Windows 7. We have a copy over here. It is even signed copy. And we'll ask a question later on through the presentation, and we'll see who will get the book. And if you all stick to the end, we'll raffle for the iPhone. Seriously. Okay, so what are we going to talk today? First, we'll try to understand why are we here. What are we trying to solve? How do we make the world a better place? Then, obviously, we'll use the only tool we can have, which is the Windows API Code Pack. And we'll get acquaintance with it. We'll see some demos and more demos. And at the end, we'll talk about the roadmap, and we'll understand where do we go and how can you help us. So to start with, I think there is one thing in common for everybody in the room, at least I hope. We are all writing and developing application. Most likely, you're targeting a Windows client, either an XP or a Vista or a Windows 7. And I hope, or I guess, that most of you are using .NET. So at some point, I'll need to ask questions. So who's actively writing application for Windows 7 today? Okay, a couple of hands. Is anyone over here in the room is a native developer or only native? No? So the rest are managed. Yeah, I guess so. Cool. So as we write application, we strive to make the application, perform it as their best on any OS that we install, either as an XP or Windows 7. We don't do it on Vista, of course, but yeah. So as we do that, we will probably want to try to take advantage of specific features or try to make the best experience or to create the best experience on a given OS. And with Windows 7, we have no exception, right? It's a great operating system. It runs very well. It uses less resources than its predecessor. It performs better, and eventually it provides new and exciting features, both for developers and users. So things like the taskbar, shell libraries, we have multi-touch, we have some older features that come from Windows Vista, like Restart Recovery, we have Trigger Start services. Some of those you've seen today keynote and heard about them. So there is a lot that we can do it. And I would like to show one or two examples of such application that take that experience on Windows 7 to the next step, adding more value to the user. So one of the applications I want to show you is something called Fishbowl. And Fishbowl is the WPF version of the Silverlight application that you've seen today during Scott's keynote for working with Facebook. So the Silverlight is beta, and in beta mode, Silverlight 4, and the code of the application will be provided later in the year. But if you want to do it now, today, if you want to run on natively on a Windows client, you have something called Fishbowl. And basically, you get the same experience. You have all the features that we have in Facebook, right? You can see through messages over here, and it's pretty quick. You don't have to wait, and you can check all your friends. I don't have that many friends. Profile, notification, and etc. And the thing is that what I want to show you is how this app utilized the taskbar, for example, to provide a very good experience. So right-click on the taskbar. Obviously, we are, just to make sure that you guys, you can actually see. Just to make, so right-click on the taskbar, from the jump list, we see all the notifications that we have, and some tasks that we can do. And if I'm going to hover over the icon, I'll see obviously seeing the preview. But also you see some thumbnail buttons that you can actually click, like check your friends, or check yourself, or see everyone's photos, and so forth. One of the tasks that you can do over here is switch to a mini mode. So an application now will switch to a mini mode, which is this thing over here, and you can obviously browse with windows. You can click, and then it will go back to your to the app itself. Right-clicking, and you can actually see that the app changes itself and change the jump list and change it from the switch to the mini mode to a fishbowl, and so forth. If I close the app, and right-click, you see again that the context of the taskbar changed to when the app is closed. So I can either go to facebook.com, which I could do in any case, and I can launch the app in any specific instance. Or I can launch an instance of the app jumping specific to any particular functionality within it. So this is just an example for a taskbar, which is really cool. Another one of the samples maybe that you've seen today during the keynote, if you notice, is the Kindle for PC, which is basically a Kindle app for PC. And this application uses both multi-touch and taskbar. So right-clicking on the app, you'll see I got the specific, the most recent books that I read. I have several tasks that you can work with. I can take my finger. Here's the mouse. I don't have a camera on me, but you'll have to believe me. I can flick. I can move between. I can zoom in and out. And that's just a great experience that you can provide on Windows 7. I have another one for you. This is an app called XP to Windows 7. Well, yeah, it's called Photo View, but we call it XP to Windows 7 because basically it shows how you can take an application. This is a WPF application. How you can take an application that works on a Windows 7. Sorry, it's how you can take WPF application that works on XP, Vista, and Windows 7. And on each version of the OS, we actually light it up and add more features as we go, which features that are provided by the OS. One of the examples that you've seen, I think, was the sensor. And I guess I need to, plug the sensor a little bit too late. I do have sensors, right? Yep. So here's the picture, or whatever picture do we get. And I have a sensor board here. We'll talk about a sensor board in a second. You see I can tilt. You see the X, Y, Z are changing. And if I'm going to change the amount of light that is being presented, on the light sensor, you'll see that the color will soon change as well. It become darker, and let me just hide this so we can actually reduce the amount of light, and it changes the color. Okay, So these are just few examples of apps that we can work with or features that we can utilize in our application to make them perform better or behave better or provide new functionality when you're running on Windows 7, which is the ultimate goal, to create a better experience. So we're all developers. We have established the fact that Windows 7 has some cool features that we want to use them. What next? Well, surprisingly or not, we discovered that all the APIs that we've just seen expose a native Win32, COM, whatever you want to do, API, right? And if you look at the .NET Framework today, you don't really see any managed API that you can use, right? There's no Windows 7, there's no anything else, there's nothing else in the framework that you can actually leverage today. So what are the solutions? You can interrupt, right? You can write your own code, you can take the unmanaged code, all the APIs in this SDK, they are just there, right? There's no secret there. And you can write your own code, your own managed code to Rapidas. However, when you come to do the task, you kind of figure out that, hey, this might be a little bit complicated, right? There are several different layers of integration between managed code and native code, as these slides show, and pretty much take it from the easy to the hard. Some things are very easy, like just using directly whatever the .NET interop facilities allow you to work with. For example, anything that has iDispatch, anything that has support COM automation, like the Office. This is one of the reasons that Silverlight uses that so easily. Then you can go through the different stacks. You can use C++ CLI or pinvoke, and you can consume COM and etc. And you get to the point that some interfaces in the OS are really, really hard to integrate with. However, we would probably want to integrate with, like power management or network awareness. It would be nice for some application to know, maybe there's a scenario that one of the applications need to know if you're connected to the network or not. And basically, for managed code, it's really hard to do. So, who has an idea? What is the solution? Manage wrappers. The title of this session, right? The Windows API Code Pack. So, first and foremost, the full name of the Windows API Code Pack is Windows API Code Pack for the .NET Framework. And basically, the Windows API Code Pack is a free source code library that Microsoft provide, and you should consider this as a code that you have written, right? Microsoft do not provide the support. By support, we mean you cannot call customer support and say, hey, I have a bug in the library, what do I do? However, we do provide all the source code so they can actually try and work it out, and it's a great, great starting point for managed code developer to take their matter through their own hands, basically, and utilize the .NET, utilize the framework, utilize this library to access Windows 7 features and work with them. So what do we have there? We got a great shell integration, really, really good shell integration. We'll see in a second. It includes the taskbar and include libraries. We got support for DirectX. We'll see it in a second. We got sensor and location, sensor, no location. We got a Windows Resource Manager, Power APIs, and so forth. Where can you get it? You can get it from codemsdn.com /Windows API Code Pack. And over here you can get the download, discussion, issue tracker, report bugs, following bugs, and so forth. If we want to take a second and actually look at the thing, over here, and I probably should have shown this before. So basically, let's look to the right. And this is the API Code Pack. I just downloaded it from the internet and opened it with Visual Studio 2010. It works on Visual Studio 2008 as well. And if you look at what the code pack includes, so include a core project, extended linguistic services. We'll talk about it maybe later if we have time. A sensor and a shell. And out of the four, the shell is the most comprehensive one. It's pretty much about 80% of the entire code base over here. Some numbers about the API code pack. So, any ideas how many lines of code do we have here? Just off the bat. Numbers? Numbers? No one? 20,000. Who wants a book? I do. So give a number. I mean, I do. Yeah, well, you got about close to 60,000 lines of code over here. And if you want to take a look, for example, what do you have and why do you want to use the code pack instead of creating your own wrappers, all you need to do is like just go for, for the core native methods, take a look at the signature and say, interesting. Marshall, untype, long pointer, wide string, lovely, right? And this code is full of those things. And there is if you look specifically, you will see that almost for every project we have an interop layer and a very extensive interop layer in some cases. And these provide the base on which we create another layer of .NET for the abstraction up to the point that we get to the point that is very easy and convenient and in a .NET way for developers to work. So that's a framework. And if you download the API code pack, you would over here, you would find that it includes the source code for the library itself, including a folder with DirectX that has its own solution because it's a managed code. It's a managed C++, so it's C++ CLI. And if you look more carefully, you see samples. We got plenty of samples, like for the shell, for example, all of these. And most of the samples include VB and C# as well. So here's an interesting question: who's using VB? Okay, the rest are using C#, I assume. Yeah, as suspected. No worries. VB is cool, sometimes. No, really. It is. Yeah, you can't, make difference between your, the tools that you work with or anything like that. What else did I want to show in this regard? And I guess nothing. So let's move forward. So today, imagine that you have not seen this slide. Who is working with the API code pack today? So I got a few hands at the people who actually wrote Windows 7 application. Are you targeting, so those who are thinking or want to use the API or the Windows 7 with managed code, are you thinking of using the new feature that we've just saw? Any idea? Never mind. Let's move forward. Anyway, today I'm happy to announce that today we release a new version of the API code pack. It's a kind of a minor version. It's 1.0.1. Nothing too excited to be nothing too exciting. However, we did fix a very large amount of bugs. Make sure that we don't leak too much memory. And in boost performance, specifically around the taskbar, the way that we provide the thumbnail preview and etc. We added some wrappers, some additional wrappers for the DirectX. And actually, if you go through the website right now, you will see that we have the what new section in this online. So 20 minutes into the session, let's see some code. Specifically, the Windows API code pack includes the shell. At the shell, you have obviously the taskbar, which we all expect. Libraries support as well. We have some controls like the Explorer browser. And the nice thing about the API code pack, it gives you a really comprehensive solution or a way to work with the Windows shell. And you can do a lot of things that you wouldn't expect from regular managed code app. For example, you can have this. So basically, it's Explorer browser. It goes goes to the shell, goes to the tree, to the highest level, and basically you can follow here. We are hosting over here Windows Explorer, and you can see that you're kind of go into a library, or if you want, go back to the desktop and to your computer, you can go to any of the drive. Right now, CD is spinning. You can see, you can get specific information about that, all the folders. You can change the view. You can do all that pretty easily with .NET, and you have a complete access to the shell, which is quite amazing and you can do a lot of stuff with that. More demos, more samples. Let's go back. We got this one as well, which is one of my favorites. And it's similar, but a little bit different. It simply provides a lot more information, and you actually can see, you can go through from the desktop, which is the highest, the highest node in the shell, and you can just go through anything that you want. The full control panel, you can get access to everything over here, through here. And basically, that means that you can access those, you can actually work with those objects eventually, which gives you full access to the machine, which is something that .NET programmers are pretty much not aware of the capabilities they can actually do that. Specifically, I guess you're more interested in stuff that are relevant to us, so let's move forward and talk a little bit about Windows taskbar. So I don't think I need to introduce the taskbar or its features, so just to make sure, we got icon overlay, ability to put icons on top. We have progress bar, we'll see in a second. Jump list, toolbar buttons, little buttons that you can add to your toolbar, to your preview, a thumbnail, and you can actually customize those. So if you want to add tasks to a jump list, any idea what you need to do? It's rather easy. You get a pointer to an iObject collection, you create an iShell link, you add an object, you add it to the custom destination, and any idea what's wrong with this code? What? The pointer? Well, the pointer should be there because it's a C++ code. So I guess the right answer is, hey, it's not managed. So here's the equivalent in manage. Rather simple, right? So we took all that work for you, and we did it for you. So if we go back to the API code pack, for example, and if you look at the taskbar, we'll see it when we do the commit. Yeah, okay, in a second. So the same thing. You want to add a thumbnail to your taskbar? Well, again, for managed code, it's even worse because these guys now have to register for a specific window message, wait for that message to happen, because only when the taskbar is created, you're allowed to actually interact with them. At that point, you actually create a taskbar button and do this and that and whatever. So with .NET, it's rather easy. For WinForms and WPF, we need to split those because the handle to the window is being accessed in a different way. But basically, you have add buttons to the taskbar object, to the taskbar manager, and then you can actually add an array of toolbar buttons that we'll see in a second. So same things go for customizing live thumbnails. Again, you have to, in the WinProc, you have to listen to specific messages and work with them and so forth. So I hope you're getting to the point that you're realizing why do you want to use the Manage API code pack instead of actually creating those on your own. And here is an example, right? So this is a code from the code pack. This is on the taskbar window manager, and basically this is the dispatch message. So obviously, somewhere in the background, we cannot escape or we cannot avoid the fact that we do need to work with the native API, but we're doing it for you. So over here, you can actually see that how. This is where we're basically listening to all messages that are coming through. And this is already, from the taskbar native method, so we are already taking one layer above the regular stuff. And we are actually listening to whatever happens. So if the taskbar button created, then we add the buttons, even if you add the buttons before or after the message happened. If you go over here, where you have enabled thumbnail, so when you have this is the activated, or when you have the DWM send icon thumbnail, basically saying that you're hovering over your taskbar icon and over the icon of your application, and then the preview pops up. So at that point, if you intervene, you will get that message, but you will not get that message because we did it for you. So just again, just as an incentive to why do you want to use the API code pack instead of writing your own code. So I guess we get it that it's kind of hard doing it in traditional C++ or creating your own wrappers. So we're going to cover that we have, with a thumbnail toolbar, you can add buttons as we've seen. You can set icon overlay. And again, we distinguish between WinForm and WPF mainly because we need to overcome the fact that WinForm are HWin based, which is good because this is how the taskbar and multitask, for example, wants to work. WPF is not HWin based, which is also good, but you need to provide some some different parameters into it, into the app, sorry, into the function, and we're doing the process in the background. Okay, some real demos. So this is here, jump list. Let's run this first and see what happens. So this is one of the sample in the Windows API code pack. Very simple WinForm app that simply goes through almost every feature that the taskbar has and show you how to do it. So over here we look, we hover. This is the basic preview that we expect to get. We get it for free basically. And right-click, there is no jump list. Cool. You can change icon if you really want. We're going to see it later in a different app. So you can change the icon over here. You can play with the progress a little bit. So you can start, you change, you can pause, you can change color if you want, error, and etc. So the thing I want to show you is actually how easy it is to add a jump list. So again, there is no jump list right now. And I want to for example, add a task or tasks. So I click on that task, and again, right-clicking, nothing happened. So maybe we need to add a link, and right-click, and again, nothing happened. So any idea what do we need to do? Refresh. Right. Sharp people. You hit the refresh, you hit the breakpoint that I placed there. I'm going to run through. Later, we're going to see the code, and voila, here is the task that we created, 3 tasks, and custom category. So let's see what do we need to do. How does app code behind look? So I'm not going to cover everything on the taskbar, so I'm not going to explain exactly what's the program ID and app ID. Just saying that if you are customizing jump list and you are working with the taskbar, make sure you know what they are and work with them. We have a jump list object. If we're going to inspect, for example, the jump list object, this is basically the main object with which you are manipulating your jump list. You can add user task. You can clear all the tasks. You can create jump list. Obviously, static, we'll see it in a second. You can work with the known category like recent and frequent. You can get max slot in a list, right? So if I'm right-clicking on the list, there is over here, there is a number of items. And if you don't change the defaults, you will get only 10. If the user doesn't change the default, you cannot change the default for the user. And so forth. So we have a jump list. We also have something called a taskbar manager, which is pretty obvious, the object through which you are working with the taskbar. So again, you have the application ID that you need to set and can work with. You can set application. You can set the the overlay icon. You can set the progress state, which is the little bar that we have seen. You can set application ID for a specific window. If you have multiple windows, you can group them all under a single button, or you can, separate them into different windows or different taskbar icon. And you got the thumbnail toolbar manager, which are basically manage all the buttons that you have on your toolbar, on your preview over here. And you have the thumbnail preview, which is basically will allow you to do this, to control this, the preview and change and provide your own custom switching. We also have jump list custom category, which is basically a collection of whatever you provided, either a task or an item. So if we want to add a task, basically, all we need to do is call the jump list, which we already created. We add user task, and we go in and add a jump list link. A task usually can point to a link. Basically, it's a shortcut. We are providing a path to Notepad, and we are giving it a title that is being displayed in the jump list. And we can also add icon reference. If we don't, it will be this default that is as if the icon is missing. And the icon is taken directly from the Notepad exe or a DLL or whatever you want to provide, and we're giving the index of that icon, as we do usually in Windows. Moving forward, we add more tasks. One of the tasks over here, we have the jump list separator, which is this line. So you see, if you look at the API callback, for example, if you look at the jump list, which is in the shell, and you have the taskbar over here, so you see that quite a lot of classes over here, including the jump list and the link, and we have everything from the thumbnail, we'll see in a second, and the taskbar manager and interface. So you have quite a comprehensive set of classes that you can work with and achieve basically, you have 100% fidelity to everything that you can do with native code. And if you remember the refresh, so basically, if you take a look, for example, at the refresh, we'll do it from here, taskbar, jump list. So if you remember, probably not, but just in case. So this is real code, by the way, a little bit abstract, but it's a real code. So you create a collection, you work. At some point, you are beginning the list, and then you need to commit the list. Right? This is the API that you work. If you read the SDK for native, for the managed code, you will see the same thing. And the reason you need to do it is because behind the scene, what happened in the OS is that all these items that we have over here, all this list is being maintained in a file. And the file contains this list and a bunch of other stuff. The removed item list, whatever is pinned and not, and etc. So at that point, where you have all that list, and you are creating a new list, like adding taskbar items, or adding tasks, or adding items, or creating your own custom categories, the Windows creates a new list on the side, and then when you hit the refresh, which basically goes through a begin list, you add custom category, you add your task, and etc., and then you commit the list. The committed list will save that folder, and in the background, you only switch pointers between the two objects that actually present that. So if the user by accident trying to do something and right click or not over that will not have any contingency or any problem with it just is if just at the same time. Right now we are trying to persist to disk or anything like that. So that goes in the background. And again, what I'm trying to show you is that the API callback basically abstract all of that from you, right? It's very easy. You just need to do the refresh. You don't need to do anything else. It's that easy. The reason we didn't do the refresh automatically for you basically could be, the only option to do it is every time that you add something, we're going to call refresh on your behalf. And any idea why we didn't do it in the API callback? We'll take it for the book. It's a nice question. Sorry? If I had? Why? Performance-wise, right? Yep, cool. Book, yours. Full of swag today, huh? Book, computer. Remember, we have a raffle for the iPhone. Okay, so We've seen that. Okay, it's time to see another demo. This is the taskbar. So here's the Zuba. Who attended the pre-con for Windows 7 on Monday? Yeah, so you guys are pretty much going to be bored because we're covering very similar content. Similar, but not identical. So we have an application here. It's a WPF application for managing a zoo, and it's a kind of funny application. And we mainly created this application in order to show that we can do some other stuff with the taskbar other than presenting tabs and documents. So if we run the app right now, if we take a look, just a simple app, right? The icon is there and so forth. So we can do several stuff. You can play with the icon. And instead of showing, the green, red rectangular that we've seen before, I can actually play a little bit with the icon over here. So I can change to a hippo, to a butterfly, to an elephant, and to a panda. You can also play with the progress bar, and we can clean. Some of the more interesting stuff you can do, you can pin specific animals that we have created over here. And I guess there is another one. There's a flamingo. And then when you hover, you see those. So you can see you can actually take a UI element from WPF and just use that as a thumbnail preview. So it's obviously show you how you can customize those. And when I click, you can actually capture that event and decide what you want to do. And in our case, we're simply going to focus on the animal. If you look at the elephant and right-click on this icon, you're going to see some pictures. We can navigate between different pictures. Hovering over the elephant, you'll get a preview, and you can use the thumbnail preview buttons, and you can change between those. And even if the application is not in the foreground, you can still do that over here. And this is the first one, and if you look at the screen. Cool. So I will minimize the app. I will hover. Does it minimize? I will minimize. I hover. I see. Remember, we are in the first picture. I want to click 3 times. 1, 2, 3. Nothing happened. This probably should be the question for the book, but I already promised. Any idea what? Okay, so the question is, any idea why nothing happened and what will happen when I'm going to click on the app again? Not on the button, when I'm actually going to click on this. So it's not the WPF. Okay, so the answer was, which is quite close to true. So it's not visible is not a problem, because if you remember when we showed it on the background, it still worked, right? So when you minimize, basically, your Windows actually disappears, right? It gets what happened in the background for any Windows, and WPF app included, it gets a very small size and being put somewhere over here, completely off screen, right? And what happened right now is when we click everything, and even if I'm going to hover over the elephant, we're going to see the first picture. Because this is the last image that the DWM remember. And this is how DWM works, right? It's not a bug in the WPF. It's not a bug in the API callback. This is how the DWM works with the taskbar. You'll get the same effect with native code. If I click, now I can have the repaint and actually update the image. So this is supposed to be closer to a deep dive. This is a friendly tip for you. It's all in the book, by the way, if anybody wants. Okay, moving forward. Oh, shit, this is the code. I haven't seen the code. We're not going to live code. We're not going to use snippet like Scott Hanselman did. We're just going to show code. So first and foremost, photo viewer. Here is how easy it is to create these thumbnail buttons that we want to create. So here's a thumbnail button, and we simply provide with the icon, and we enable it, and we add a handle. That's it. And we do it 4 times because we have 4 buttons. That's all we need to do. At the end, eventually, you want to go to the taskbar manager, and you want to add those buttons. This is some updates for the UI, and we're done. Over the zoo worker, We have the sub thumbnail, so we want to add when we click on the, if you remember, we click on the bear, on the elephant, and on the flamingo, right? So still few folks are following me. So just making sure it's not null. Over here, we're removing the element just in case it's already within the list, and then we are simply create a thumbnail preview, and we are passing the required parameters like the current window, the UI element, and something that's called offset. We'll not go into that right now. We add the activate and the close, and what happened when you do that, and that's it. And then we add the thumbnail to the app. Obviously, we need to manage the on-click event, but we'll see it later or after we finish the time because we're running a little bit late on time. So this is how easy it is to work with the Windows API code pack on the taskbar. Next, I'm talking about the libraries and shell. So another part of the shell is the libraries, and in Windows 7 we have libraries. Anyone doesn't know what library is? I know, you know what it is, right? You don't know what library is? So Windows 7 library is basically a collection of different folders. Those folders can be either on your local drive or in a network share. And what libraries are doing for you is if you go to Explorer, let's create a new instance, and over here you see the libraries. We have a demo library that we actually need to delete because it's something that we need to create. Yes? So we have the default document, music, pictures, and so forth libraries. So if I click on the picture, for example, if you see over here, we are actually aggregating different folders from different location on my hard drive into one place, and this basically allowed me to view the images and view the pictures in a different way. And I can have here all the pictures, so it aggregates all the location into a single location. Search will go and search into this. You have different tags and filters there over here, depend on the type of the library that you can work with. So very useful, very users like that because basically they can aggregate now all the content into one place. They don't have to work with multiple content, as we found through research that they actually do. So for developers, what do you need to make sure? You need to make sure that you're using the right common file dialog. The right one basically means that you need to use the new version, which was presented in Windows Vista. For managed code developer, you need to use the WinForm common file dialog. And in WPF4, you actually can use the regular WPF dialog. We have a default save library. We'll see in a second. And there are APIs. So as far as the API, for syncing those, if we're going to look at the demos that we have a library manager over here. And it's a WPF application through which I can actually go and run it. Here's the app. And basically the app right here. So what I want to do, I can, for example, create a new library. And I'm just going to give it a name, like a demo. And I click OK, and here it is. Here's the new library over here. It's empty, obviously. I can add a folder. So let's go pictures, whatever, doesn't really matter. Add a folder. Here's the folder. Let's go to the demo library. Here's the folder, the one folder that I add. I can do the same thing from the Explorer, Windows Explorer. I can click the location, but actually I want to do it from the app, so now I can actually click on the library manager and doing the same. So everything is being driven from the code. Other thing I can do, so let's make sure that we have one folder over here. Go to demo location. Let's add another one. Already have that. Add a folder. Okay, so the folder is over here. And if you go to your app, it's also over here. And the reason is because we can actually stay in sync and we can listen to changes that happen on the libraries, be aware of that, get notification, and we can update. We can also change the icon if we want. You can choose a different icon. one of those, and here it is, you see the icon change. We can actually control if the library is pinned or not to the navigation pin. So where's the pin? So I can actually press on the pin, and I can actually do that. Cool. Code behind, extremely, extremely, extremely easy for working with libraries. It's in the, this one? Nope, it's over here. You want to add a folders. Presenters, my bad. You want to add a folder, all you need to do is use something called shell library. You want to load the library, and if you're going to look at the shell library for a quick second over here, so it's a container for shell, and it contains basically implements shell file list of folders and enumeration of collection, and it basically allows you to, as a library, to work with whatever you can do with the library through the UI, through the native API. You can still do, or can do the same thing with managed code. You can create new libraries. You can, as you saw, for example, you can change the icon. You can set if it's pinned or not. You can work with known library. You can add, remove. You can actually remove the library itself and so forth. So a lot of stuff over here, and it's extremely easy to use. You can see literally every function that I have within the WPF app eventually corresponding to going to this code, like here is how to remove a folder. Simply remove the folder. Open the UI manager, not very complex. You just need to pass the owner, give some parameters. If you want to delete a library, basically what you need to do, you need to delete the file, the XML file that the library represents. If you want to learn more, you need to go into the library and actually take a look at what's going on over there. Okay, so that's with library. Moving forward, and we'll do it like real quick. Yeah, if you want to do a library, this is what you need to do. So this is how the C++ code looks like. This is how easy it is. And we did the libraries. And sensor and location. So who have seen any demo of sensor and location in his life? That's it? All of the rest haven't been in the, who've been in the keynote today? I guess everyone. So if you remember, you've seen a demo of a sensor because Michael or Steven, play with the color of the flower. And so did I about 15 minutes ago. So sorry if it didn't resonate. Anyhow, we have a sensor and location platform in the Windows 7 OS, and basically what it provides developers is a very easy way to access sensor. A location device is also a sensor, so we only will we'll talk about sensors. So basically, it's a unified API that has all its perks for hardware vendors, but basically for a software developer, there is a really easy way for you to access sensors, get information from them, and write your application. Why do we need sensor? Well, basically, I think it's pretty obvious that when we write application, we write them for the current condition that we are, right? We sit in the office, we sit in front of our PC, here's the app, here's the desktop, monitor, keyboard. We write, these are the pretty much lighting condition that we are at, and we are building and testing the app for the current environment. Now, here is a laptop, right? I have an app. I take the laptop out. I'm sunny LA. Never happens by the way, in Redmond. Don't get sun there at all. But you go out, so we don't need to test against strong sunlight. So you go out, and basically what you expect is you look at the screen, bright sun or bright light coming at the screen. It's glare. It's kind of hard to read. And ambient light sensor is just one example out of many. And eventually what you want to do is maybe we can opt in. Maybe we can provide an experience out of the box that is different. So we can actually, and it's rather easy. if we're gonna close that, how did I do that? So what I'm going to run here is an app called MSDN Reader, which is a WPF application that basically is light aware. And what do I mean by it's light aware? You will see in a second. But it's an app that displays text and images. And for indoor use, which should probably look like this. Should be just the opposite, right? A lot of light. Come on. Oh, my bad. Yeah, I have to cover. That, like, anyway, when you cover, let me hide it from light. As you see, this is how you will normally expect to see, right? If you're sitting in an office, this is a really nice view. But when you step outside to the sun, as you see, the app a little bit change, and we increase the font size, we reduce the use of color, and basically, if you take that version of the app out into a very bright environment versus this version of the app, it will be a whole lot easier for you to read, right? A different example we're gonna take a look at the quick game, but I actually do want to show you the code before we're gonna view the game itself. Let's go to the solution. So if you look at a sensor in the API code pack, we have a sensor project over here. We got a bunch of stuff. Obviously, we got the interop layer. You really don't want to go over there. We got the metadata, interesting, but not for now. The important thing is that we actually do have sensor here, real sensor. And the reason we have real sensor is, and we only have two, we can actually have a lot, is because with .NET, you can actually create objects that you can work with, right? We have function properties you can bind through, and basically the only thing that you need to know when you create your own sensor is what is this GUID it's representing. In the sensor SDK, in the sensor.h actually file within Windows SDK, you have all that list, and that's it. See, there's pretty much nothing over here. You simply create one and you call the base, and if you want to enumerate this one is an accelerometer, so you can have the X, Y, and Z access, and you simply, this is how you get a data report and get some information from that. That's all, and even that we have already created. So how does it look if you want to use that? You go over here, and let's check the game logic input. So in the input function, let's go over here. So when we create this specific object, we go to a sensor manager. For the sensor change, we bind a event handler. Sensor manager, as its name, it's the manager of all the sensor through which you can discover new sensor and get events when new sensor arrive. Eventually, we're getting all the sensor from the specific type, which is accelerometer, which will give me a way of getting the specific orientation of this board in 3D space. I prepare the sensor with basically doing some binding and making sure I have access and so forth. Again, we don't have time to cover everything with sensors. This is about the API code pack, but the idea is I want to show you how easy it is to integrate. Eventually, when you go through everything, you get your sensor over here, and you read a data report, and then you get the X and Y force, or basically the current orientation of the board for the XY axis. We don't need the Z axis because we are writing a game that we're going to control a car, so you don't need to have a Z axis. And if we run this thing, and this is where we need sound from the laptop, it will take a second. Anyway, when you run this thing, you'll be able to eventually get the information. So it running. It's trying to. Okay. Start the car, any car, as long as it's red, a car. Easiest course. Obviously, so the board is here, not touching the board, right? I can use the keyboard, right? I can drive with the keyboard, but I can also drive with the board. So, forward, accelerate. See the speed goes up. I can tilt the board, triangle. Backward decelerate, and I can drive. And if you notice, we hadn't had time to actually go through the code, but I'm also controlling the shade of the sky. So we pass the sun. So if we're going to cover the light sensor, you see that the sky has turned into black or a bit darker. If we're going to show it to a bright light, like we have over here, it becomes blue sky. Okay, enough crashing the car. So, thank you. Maybe I should do justice, if I would have shown 10 different games, will I get applause for each one? So basically, if you look at the shaders, for example, it's really the same thing, right? When over here, when we construct the object, this specific class of the game, we take the sensor manager, we're doing the same thing. We are binding events, we're getting specific sensor. This time we're getting an ambient light sensor. We call the prepare method, and again, we're following the same process. This time we're actually gonna bound to a data report, which is the event that happened when we get information from the light sensor. We didn't need to do it for the accelerometer because we actually poll that. We're using polling, but it doesn't really matter. You can do them both. So we are short on time, so let's just get to the end. So we didn't cover everything, right? We cover only few sample of the shell. We cover a little bit of the taskbar libraries. We've seen some sensor. There's a lot of other things in the API. If you're thinking of writing a managed code application for Windows, please do consider working with the Windows API code pack. As far as roadmap, today you have the API code pack. Tomorrow, when Visual Studio 2010 ships, you will have some elements. You will have taskbar for WPF. You'll have multi-touch for WPF. You have location, which basically provided through a new namespace in .NET 4, which is system devices location. But for all the rest of the features, you will still have to use the CodePack API. And as you've seen, I'm working with it in Visual Studio 2010, so it just works. As far as the roadmap, we have released several versions. This is only the last few. We released with Windows 7. We released version number 1. Today we actually announced the 1.01. We can definitely say that we're going to have another version, which is 1.5, which includes some fundamental investment in documentation, performance, adding more stuff to the core of the API. And we think, we're not sure yet, but we think we're going to have another version which will add more stuff to the API, like location, resource recovery, trigger start services, and etc. So, what you need to do, if you're going to start working, or if you're going to start developing for Windows 7, make sure that your app is running, installing correctly on Windows 7. That's app compat. It's utmost important. Optimize your application for Windows 7, taskbar, share libraries, few of the examples that we've seen today. And then you can create amazing new experience with a sensor, with multi-touch, DirectX, Ribbon, and some other stuff that we haven't covered. Plenty of resources on MSDN. We have training kits, so almost everything that we've covered, or actually everything that we've covered, can come from Channel 9 has a new learning center, and this new learning center includes a Silverlight 4 training course that just came out, but it also includes Azure, HPC, Identity, Office, SharePoint, Silverlight 3, actually the same Silverlight, sorry, Studio, and Windows 7 and R2. If you go to Windows 7, you actually have, you have almost everything here. Multi-touch, taskbar, sensor. It heavily uses the API code pack, also for native developers as well. With that, thank you very much. And thanks. If you have any question, now it's the time. Please fill up your eval. I've been told that for every eval, Microsoft donates money. Yes? Mm-hmm. Yeah. So there are a few answers to that question. One is either you check on your own and you don't do anything, or you actually take procedure, either you want to do or not. A second, in the API callback, if you're trying to access API that are not present on Windows 7, you will get exceptions that you can work with. So you can do preemptive or responsive, whatever you want. Recommended, you're asking for what is the best recommendation. The best recommendation are to check for features, not for versions. With native.
Are there examples of how, because everything online says to check for features, but nobody tells you how.
Okay.
Are there examples anywhere of how one might do that?
Yeah. So it's very easy for C++ code. You simply try to load a DLL. If you failed, you know there is a problem. For managed code, there isn't really any way to actually load a library and check it out, right? It doesn't gonna work. So in the XP to Windows 7, and I'll show you the code later if you want. What do? We write a plugin. We wrote a plugin infrastructure that actually checks eventually for versions to make sure what runs where, right? But it checks the minimum version. We check a minimum version, not a specific version. So for example, we have a feature called Restart and Recovery, which allows you to register if your application crash or being asked for restart. And it's present from Windows Vista. So we do not check Vista 7 and etc. We ask for the minimum version of that app, and we take it forward from there. So
how does that affect our second follow-up question would be, how does that affect our applications as we go to develop this against an API code time?
Yeah.
In 2010.NET 4 beta, and then what? I mean, it shows up in .NET 4 and it just keeps working.
So right now, they can both work together. So you can use the taskbar in WPF or the taskbar in the API code. So the question was what the relation between the API callback in .NET 4 and how to work with them both, or what will be the future. So if it wasn't clear through the roadmap slide, we cannot say that everything in the API callback will become part of the .NET framework, right? We cannot say it now for certain. We want, we wish, who knows? For WPF4, we have the specific set of API that will work, and the rest you will have to use the API callback. Specifically, if you're talking about taskbar, for example, so the taskbar will work with both instances. You can either use that or that. You will start having contingency if you're working with the same program ID. Eventually, the native API will see both and act upon them both. So it will maybe have race condition or whatever according to your .NET application. For example, we're thinking of adding the location to the API callback because right now it only supports sensor. If you're going to do that, we're definitely going to have very similar namespace to the one that exists today in WPF4. You'll just have to switch between them. But if you want to develop something today and ship it for Windows Vista, or sorry, for Windows 7, which already has 3.5 in it, and you don't need to redist .NET 4 with it. But long term, we are looking for solution from the framework.
You maybe addressed this already, but if I take this application, right, and run it with 3.5 in XP,
yeah.
What's going to happen?
So if you're going to if you're going to work with the taskbar, for example, and call a function, you will get an exception. Yeah, like feature not supported on something. It's better if you actually check before you do that. Yeah, it's simply.
One more question. So WPF or Windows Forms, I mean, if I to develop a new application, I know that I have some experience with Windows Forms and I can develop quicker with that one. Does it make sense to take another step, and switch to WPF rather than Windows Forms?
That's
And in, you know, in context with
That's very subjective to you, to your application, to the needs, to the requirements, right? If you need a simple app or a comprehensive app, user experience, graphics, think flying or not. Eventually, maintenance will probably be easier with WPF if you know WPF. WPF is very powerful. The learning curve is a little bit, long. However, it could be very, very powerful and effective if you know how to use.
So, but it doesn't really.
It doesn't matter for as far as the API code pack. It doesn't matter. No.
Okay. Thanks.
Sure.
Where'd you get your sensor board?
Freescale? Yeah, you can buy. You can purchase them online. Yeah, you're not the first one to ask, so I'll write a post on it.
So these laptops that you got,
So these,
program for that?
yes, these are RAT sensors. They do not have the drivers right now. If you, wait. Yeah, it really is awesome, by the way. However, drivers will be deployed probably in the next week or two through Windows updates for the sensor. If you want to make sure, you can simply go to Device Manager, or you can go to your sensor and location in the control panel. Both will show you the same thing. Here are my sensors. I had a couple of them right now. And if you look at the sensor device and location, you have the same thing. If you don't have the drivers, the screen will be empty. But yes, you do have sensors there in the machine.
Where'd you say you post that? Sensor board?
I'll put it on my blog, which is the Windows Team blog. Specifically, if you want, you can get it right now. Freescale, Gavin. Yeah, Gavin Gear's blog has a very all the information. Here it is. Question? Hurrah. Of course. Here it is. Enjoy.
Great, thank you very much.
Yeah, we're done. Cool.